Alright, welcome back. So now let's try and put all the stuff we just looked at to use. You have three examples on the sheet in front of you. I've spread them out so I have a bit more space to work with them. But I'm giving you a point on the terminal arm, and with that I want you to determine a lot of information. So first of all the primary and reciprocal trig ratios, a point that we're going to use to find the related acute angle, the calculation you use to find the related acute angle, and we're going to eventually find the angle that goes to this terminal arm. Let's start with this. There's a lot going on here. Let's try first make a sketch. So let's look at the first one here. So we have the point 3, -5 that's on our terminal arm. So I'm going to start with our Cartesian plane. Okay, and 3, -5 is down here. So that's going to be in quadrant 4. Okay, so I got this point here at 3, -5. Okay, so when I have that now this is going to create a triangle with the nearest x-axis. Okay, now just for illustration purposes here, this right here is my theta. Okay, so because it's a principal angle between 0 and 360, it goes from the positive x-axis to my terminal arm, and the angle I'm going to have in here is going to be my alpha. Okay, that'll be my related acute angle. So when I'm labeling this triangle here, I'm labeling my sides. So here, if I'm trying to label the sides of this triangle, this will have a side length of 3, and this will have a side length of 5. Okay, so again, this is because I'm going to the point 3, -5, so distance of 3 here, distance of 5 here. Now, I can find the missing side of the triangle because I know those three sides are related through Pythagorean theorem, so I'm going to call that r. So r squared will be equal to 3 squared plus 5 squared, which you can run through your calculator, and it should tell you 9 plus 25 is 34. Square root would be root 34. Okay, so that will be the length of this side right here, square root of 34. Okay, that's my r. Okay, so with that in mind now, I'm actually going to try and find all my trig ratios. Okay, so notice in this triangle here, this is my alpha, okay, but I might want to find the ratios for theta. So for sine of theta, I can actually use the related angle here, because the related acute angle here, it is actually going to be having the same ratios as the ones from theta. So again, because I have related angles here, the magnitude of sine theta will be the same as the magnitude of sine alpha. Okay, now when I say magnitude, I mean it could be positive, could be negative, I'm not sure. Okay, so they'll have the same value, they'll just be off by a negative sign. So if I actually want to find whether or not, if I want to find the ratio for sine theta, I can actually work with sine alpha and then be able to find my my sine theta from there by looking at whether my ratio is positive or negative. Okay, so enough talking, let's actually do this. So looking inside this triangle here, so sine is opposite over hypotenuse. So that's going to be 5 over root 34. Okay, but that's for my alpha. Okay, I want to actually find theta. So again, my angle is now in this quadrant. It's in quadrant 4. So is sine going to be positive or negative in there? So let's take a look at my cast rule here. C-A-S-T. So my angle is in quadrant 4, where cosine is positive. And if cosine is positive, the other ones are negative. So sine theta will be actually equal to -5 over root 34. Okay, so again, I got 5 over root 34 by solving the ratio inside the triangle using alpha, but since that's alpha and I actually have theta here, it's a different angle. This angle is in quadrant 4, so in quadrant 4 the sine ratio is negative. Okay, let's try again with cosine. So cosine using this triangle is adjacent over hypotenuse, so 3 over root 34. Okay, so if it's 3 over root 34, now let's check, see if it's positive or negative. So in quadrant 4, cosine is positive, so my ratio will stay positive. Okay, and last but not least, let's look at tan theta. So for tan theta, we're going to have opposite over adjacent, so 5 over 3. Okay, and is the ratio going to be positive or negative? Well, in quadrant 4, again, cosine's positive, which means tan is negative. So these will be my primary trigonometric ratios for theta. Okay, now if I want to find the reciprocal ratios, again, I just take the reciprocal of the ones I already have. So for cosecant, it will be negative root 34 over 5. For secant, it will be root 34 over 3, and for cotan, it will be negative 3 over 5. Okay, so again, what's a little different here is, again, we're trying to find the ratios for theta, which you can see is not an acute angle, right? It's going all the way around to quadrant 4, so it's somewhere between 270 and 360. But what we're going to use instead is the related angle, the alpha, to try and find the ratios inside that acute triangle right there. And then using the CAST rule, CAST here, we can determine whether or not the ratios are positive or negative for theta. Okay, so let's move on. So now, let's say I wanted to strictly look at the related acute angle. So it's in this quadrant right here. Let's say I want to draw that in quadrant 1. Let's create a new graph here. The first one's getting kind of cluttered. Okay, so if I want to find the acute angle, the one in quadrant 1 here, if I want to keep the same ratios here, instead of having the point 3, negative 5, this would be, if I want to keep the same triangle here, the same size, this would be the point, if I go 3 here, 5 here, the point here will be 3, 5. Okay, so what I can actually do now, if I wanted to have a point in the Cartesian plane that would help me find the related acute angle and just the related acute angle, I could place that acute angle in the first quadrant and use the point 3, 5. So what I'm going to do here, again, if I try to answer part B, the point associated with related acute angle will be the point positive 3, positive 5. And where that can come in handy is, let's say I want to find the value of alpha. Now I'm not dealing with any negative values inside the quadrant, I could just solve for there. So here, if I want to solve for alpha, I could use the trig ratios I have. So I have the opposite and the adjacent side. In theory, I also have root 34 out here as I solved for that radius earlier, or that r value. So if I want to solve for alpha here, if I want to use the opposite and the adjacent side, well, tan of alpha will be equal to opposite over adjacent, or 5 over 3. Okay, so if I wanted to actually solve for alpha, it would be the tan inverse of 5 over 3. Okay, now I don't have to use tan. I could use cosine or sine. So let's say I wanted to use cosine. I could have done cosine of alpha in this triangle is adjacent over hypotenuse, so 3 over root 34. So alpha would be the inverse cosine of 3 over root 34. Okay, so I can use either one I want here. I think the one I used here was tan, but you can use any ratio you want. You could create one for sine as well. Now you might be wondering why it's necessary to necessarily draw it in the first quadrant to do this, and it's actually not. If you want to do a bit of a shortcut here, if you ever wanted to solve for alpha, you don't necessarily need to do this step in part 2. You could just look at the triangle here and say, hey, I've got a side length of 3, a side length of 5. I know how to solve angles and right triangles from grade 10. Just use, sine, cos, or tan, and use the values in here. Just be very, very careful. If you want to find the acute angle, there should not be any negative values in your ratio. If you have a negative in your ratio and you're trying to solve for the alpha, your calculator will not give you the right answer necessarily. So make sure there are no negative values in your ratio when you're solving for your alpha. One way you can get around that is, again, by drawing it in the first quadrant. So you have 3, 5, root 34, nothing negative hanging around here, even with that point out here. So again, if you're good with that, if you can recognize you can't have any negatives in the ratio solving for alpha, you don't need to do this step by drawing the triangle in quadrant 1. You can still solve for alpha just by looking at this triangle, as long as you have no negatives in the ratio. Okay, so once we have, and again, you can run this through your calculator if you actually want to find alpha. This one's just asking for the calculation. Now, if you want to run this through your calculator to see what you could get, it would be approximately 59.04 degrees. Okay, and the reason it's helpful for us to find alpha is now we can actually go through and find theta. Okay, so if we look at theta, looking at our original diagram up here, let's get this other one out of the way, just causing extra clutter. So theta is in quadrant 4. We have our alpha, so we know looking at this that theta will be equal to 360 degrees of full rotation minus the alpha. Okay, so once we figure out what alpha is from part 3, okay, you can use the expression there, or since we want to find the answer rounded to 2 decimal places anyways, you can put in the 59.04 degrees we already calculated, put 360 degrees minus what we calculated for alpha in part 3, and then we can actually find the value of that angle. Okay, so all that work was to find the value of that angle that went from the positive x-axis all the way to that terminal arm. Okay, so there's a lot going on here in one question. Okay, so a lot of this is probably new to you. It seemed kind of tricky to start. What I'd like you to do now is try to go through this entire process again for B and then again for C. And when you're ready, push play and you can go through the answers together. Okay, just give yourself some more space here as we go through the answer together. Okay, and again, if you are stuck right now, first thing you always want to do is make a sketch. So 4, -7 is again in quadrant 4. Okay, so you can take a quick second to check your answers here. But let's just run through it together here. So first thing you want to do is draw your triangle in the 4th quadrant, because again the point 4, -7 is down there. Label the sides of your triangle, so you have 4 for the x, 7 for the y. Your alpha, in blue here, is the one inside the triangle with the nearest x-axis. Your theta goes all the way around up to the terminal arm. And the first thing you also have to do is find that third side of the triangle. So again, using Pythagorean theorem, 7 squared plus 4 squared equals r squared. So you solve for r and you get root 65. Okay, once you have that, you can start creating your ratios. So sine of theta, we're going to use alpha inside the triangle to define the ratios. So we have opposite over hypotenuse, which is 7 over root 65. But because we're in quadrant 4, cosine is positive, which means sine is negative. Okay, so that negative has to be there. If you're missing that negative on a test, unfortunately, even if the rest of it's right, the answer will still be wrong. So it's really important now to, when you're evaluating trig ratios, to always, always, always check the quadrant to make sure you have the right sign on your ratio, whether it's positive or negative. So with cosine would be adjacent over hypotenuse, so 4 over root 65, and cosine's positive there, so that's good. And for tan, opposite over adjacent, 7 over 4, but we're in quadrant 4, cosine's positive, so tan is negative. Okay, you can then get your reciprocal ratios by taking the reciprocal of your primary ratios, so you can get cosecant, secant, and cotan there. If you want to deal with a point associated with a related acute angle, you can draw it in quadrant 1, and the point would be 4, 7. Okay, but again, that can be handy if it helps for the visual to find alpha. If it doesn't help you, then you can just use the triangle here. As long as you remember, if you're solving for alpha in part 3, there are absolutely no negatives inside your ratio. Okay, because you're trying to get an acute angle, and if you have a negative inside there, it's no longer an acute angle, because with a negative ratio, you're not in quadrant 1 or 2, and you're trying to find alpha, which is going to be an acute angle. So you can use either the sine, tan, or cos ratios that are up there, but again, make sure if there's any negatives in your ratios, they're not included, because you're trying to force your calculator to give you an acute angle. So use whatever one you want, solve for the ratio, solve for the angle, sorry, you get 60.23 degrees. In quadrant 4, remember a full rotation is 360 degrees. So 360 degrees minus alpha, the blue one here, will give us theta, so we can solve for theta there, 299.77 degrees. Okay, hopefully you've tried the third one, part C. If not, again, do that now, and when you push play again, the answer will be up. Alright, so let's run through the solution for this one here. So this one, you'll notice negative 2, 4 is in quadrant 2, unlike the previous two that were in quadrant 4. So we draw it in quadrant 2. We have our x length of 2, y length of 4. Solving for r using Pythagorean theorem gives us square root of 20. So then we can find our sine, cos, and tan ratios. So just like before, we can use the alpha inside the triangle here to get our magnitude for the ratios for sine, cos, and tan theta. And then we just use our cast rule to determine if it's positive or negative. So sine theta, so we have opposite over hypotenuse, so 4 over root 20. In quadrant 2, sine is positive, so it stays positive. For cosine, we have adjacent over hypotenuse, 2 over root 20. But in quadrant 2, sine is positive, cosine is negative. And then for tan, it's opposite over adjacent, 4 over 2, which simplifies to 2, but again, negative in quadrant 2. Okay, so you get reciprocal ratios by taking the reciprocal of each of sine, cosine, or tan. We're going to finish this one up in part 3 of the video, I guess now, and then we're going to take up a few more examples, and then we'll call it a day. Okay, we'll see you over there.